The objective of this lesson is to recognize squares as examples of rectangles and rhombuses, which are both examples of parallelograms. In the previous lesson, students examined the relationship between quadrilaterals, trapezoids, and parallelograms. In this lesson, we will similarly examine the relationship between squares, rhombuses, rectangles, and parallelograms. A parallelogram is a quadrilateral with two pairs of parallel sides. A rectangle is a quadrilateral with four right angles. A rhombus is a quadrilateral with four congruent sides and two pairs of opposite congruent angles. A square is a quadrilateral with four congruent sides and four right angles. We will first examine parallelograms and rhombuses, keeping in mind the question, is a rhombus always a parallelogram? We will use a Venn diagram to answer this question. In the parallelogram only section, we could add any four-sided shape with two parallel sides as long as the sides are not all congruent. We cannot add any shape into the rhombus only section because all rhombuses have two pair of parallel sides, and that is the definition of a parallelogram. Instead, we need to add rhombuses into the shared section as they have all the attributes of a parallelogram and all those of a rhombus. Since all rhombuses are categorized in the shared attribute section, we can adjust the diagram to represent this relationship. Next, we will examine the relationship between parallelograms and rectangles, asking a similar question. Is a rectangle always a parallelogram? In the parallelogram only section, we could add any four-sided shape with two sets of parallel sides as long as the angles are not right angles. We cannot add any shape into the rectangle only section because all rectangles have two pair of parallel sides created by the right angles. Instead, we need to add rectangles into the shared section as they have all the attributes of a parallelogram and all those of a rectangle. Since all rectangles are categorized into the shared attribute section, we can again adjust the diagram to represent this relationship. For our next diagram, we will examine the relationship between rhombuses and rectangles, asking the question, is a rectangle a rhombus? We will place rhombuses without right angles in the rhombus-only section, and rectangles without all four sides congruent in the rectangle-only section. Rhombuses with all four angles measuring 90 degrees would be placed in the center section. This is called a square. Rectangles with all four sides congruent would also be placed in the center section. This is also called a square. A square has all the attributes of both a rhombus and a rectangle. Another way to look at it is that a square is always a rhombus and it is always a rectangle. It has four equal sides, which is the definition of a rhombus, and it has four right angles, which is the definition of a rectangle. We previously showed how all rhombuses are parallelograms and how all rectangles are parallelograms. Knowing the relationship between these and between rhombuses, rectangles, and squares, we can create a new diagram to encompass the entirety of what we've discovered. All rhombuses are parallelograms. All rectangles are parallelograms. All squares are rhombuses, rectangles, and also parallelograms. The objective for this lesson was to examine the relationship of squares to both rectangles and rhombuses, as well as the relationship between rhombuses and parallelograms, and between rectangles and parallelograms. We met this objective by reviewing the attributes of each shape and examining shared attributes through the use of Venn diagrams.